So we have started with dependent sources. So let's proceed further with supermesh analysis using dependent sources. So the next numerical is find currents I1 and I2. That's it. So there are two meshes. So we'll have two equations. And since they have directly said find I1 and I2, they have already given the currents in the clockwise direction I1 and I2. So what is the first step? What we see here first, it is a dependent source. What is the value? 3 V0. So as we have seen in previous lectures, we should have V0 somewhere as a node in the network. So V0 is here. So what we do, we write V0 in terms of I1 and I2, right? Why we write that? Because if we write equation using KVL, we will get I1, I2 as well as V0 in the equation. But since we know there are two meshes, so we will have two equations only. So there will be two unknowns only, but we will have a third unknown in terms of V0. So we have to write V0 in terms of I1 and I2. That's what we saw in dependent sources. So what we can write from the network, what is V0 will be? We have to write V0, right? So what will V0 be? So V0 is nothing but potential across this line or this line, right? So how to write that? So we know by Ohm's law that current I equal to V by R. So if we write the current for this branch using KCL, what will it be? Current I1 equal to voltage. So what is the voltage difference? This difference. Remember this value is, this is volts, minus 10. We are going from minus to plus. So plus the value of voltage source, but the value itself is negative. So minus 10 plus V voltage difference, so minus V0. So minus 10 minus V0 upon the resistance which is 8, right? So this is what I1 in terms of V0. So find V0 from this. So it will be equal to minus 10 minus V0. So therefore V0 equal to minus 8 I1 minus 10. So this is equation number 1, right? Then simple apply KVL to mesh 1. So for the first sum I'll write in detail now. So let's start from here. So we travel like this, we should come here. So minus to plus, so plus, but the value itself is negative, so minus 10. Then this will be what? Plus minus, so minus 8 I1. Then this will be plus minus 2 times I1 minus I2. This current is also there. So minus 2 times I1 minus I2. But what is happening here? I am getting a current source. So we'll write I into R. What is the R? We don't know. So we cannot apply KVL to mesh 1. Similarly, we will not be able to apply KVL to mesh 2. So what is happening? We have seen this is a problem of supermesh, right? So what do we do for supermesh? We write the current equation directly. What will it be? I2 is in the direction of current. So it will be I2 minus I1 equal to, what is the value? Negative. So minus 3. So therefore you can write this is I1 minus I2 equal to plus 3. This is the second equation. So what we'll write here? Mesh 1 and 2 form a super mesh. Therefore, then applying KVL to super mesh. So therefore, so again let's start from here. Minus 10 minus 8 I1. So for I2 this is plus minus. This is given plus minus. So we are going from plus to minus. We don't have to see this. So minus 3 V0 plus minus 10 I2 equal to 0. And we know we have this equation and this equation, but there are three unknowns V0. That's why we have written V0 in terms of I1 and I2. So substitute that here. So minus 10 minus 8 I1 minus 3 times V0 is minus 10 minus 8 I1 minus 10 I2 equal to 0. So just solve this, collect the terms in I1. So what is it? Minus 3 into minus 8 plus 24. 24 minus 8, 16. So 16 I1 minus 10 I2 This is plus 30, minus 10, 30 minus 10, 20, and when it comes to the right side, it is minus 20. So this is equation 3. So solving equations 2 and 3. So I1 equal to I2 equal to, so 1 minus 1, 3, then 16 minus 10 minus 20. So I1 is minus 25 by 3 amperes, which is equal to 25 by 3 amperes in the anti-clockwise direction. I2 is minus 34 by 3, so plus 34 by 3 amperes in the anti-clockwise direction. So this is the answer, right? So let's go to the next sum. So again find currents I1 and I2, but instead of 2 loops we have 3 loops, and there is one dependent source. What is the value? 0.5 V1. So we should have V1 somewhere. So this is V1. So first write V1. So from the network, what will be V1? V1 is plus to minus. Yesterday we have seen in the last lecture how to write using Ohm's law. So I into R. So R is 2. So what is the current? The voltage is plus above and minus below. So current should also be in the same direction like this. So which is that current, I1 or I2? It is I1. So it will be first I1, but I2 is also interfering and it is in negative direction. So minus I2. So plus 2 times I1 minus I2, first equation. Then apply KVL to mesh 1. So apply KVL to mesh 1. So what we'll get? Let's start from here. I am not putting plus and minus because it should be clear by now. So minus 14 I1 minus 4 I1. What will this be? Minus 2 times I1 minus I2 equal to 0. So solve this. Minus 14 minus 4 minus 8 minus 18 minus 2 minus 20. So minus 20 I1. This will be plus 2 I2 equal to minus 110. Equation number 2. There is no third unknown here. Then apply KVL to mesh 2. But can we apply? We cannot apply because there is a current source. Even though dependent, this also forms a super mesh. So what will we write? So we will write mesh 2 and 3 from super mesh. So therefore, what will it be? Which current is in the same direction as current source? I3. So first we will write I3, and I2 is in negative direction of I3. So minus I2 equal to, what is the value? 0.5 V1. So now we see we have the extra unknown. So what is V1 in terms of I1 and I2? 2 times I1 minus I2. So therefore I3 minus I2 equal to 0.5 times 2 times I1 minus I2. So what will this be? Therefore I3 minus I2, 0.5 into 2, 1, equal to I1 minus I2. So therefore I1, so a minus I2 will come here, plus I2 will get cancelled. So I1 minus I3 equal to 0 amperes. This is equation number 3. So then apply KVL to super mesh. So therefore, so which is the super mesh? I'll use green pen. This is the super mesh. So this path we should follow, right? So let's start from here. So this is what, remember this plus minus is for what? Voltage. So when you are applying KVL, you are going above. So you are, and your current is what? Going above. So this is plus, this is minus, because current flows from higher to lower potential. So minus 2 times I2 minus I1. Make sure you understand this step. If you have not understood, rewind it. So minus 10 I3 minus 6 I2 equal to 0. So 2 I1 minus 6 I2 minus 8 I2. This is also there. So minus 10 I3 equal to 0. This is equation number 4. So what will write? solving 2, 3 and 4. So what will get? I1 equal to, so second equation is minus 20 I1, 2 I2, I3 0, minus 110. Third equation, I1 is 1, I2 is 0, I3 is minus 1 and 0. Then 2 minus 8 minus 10, 0. So I1 is 5 amperes in clockwise direction. I2 is 5 amperes in anti-clockwise direction. I3 is again 5 amperes in clockwise direction. What is the question? Find currents I1 and I2. So this is the answer, right? Let's solve the next sum. So this is the final sum. Again, the videos are short because I expect you to solve this in your books. And make sure you will get an assignment after completion of this module. So anyways, you will have to see the videos later. So make sure you see the videos and solve the numericals at your home. So find current through 8 ohm resistor. So first look at the 8 ohm resistor. We have to find the current through 8 ohms resistor. Again, it is a problem of super mesh between mesh. Let's say I take this as I1, this as I2, this as I3. Right? So mesh 1 and 2 form a super mesh. So I'll go fast here. I'll not write the steps. So what is the first thing? We observe the dependent sources. There are two dependent sources, so two dependent variables, Ix and Iy. So Ix and Iy should be there somewhere. So this is Ix, this is Iy. So write Ix and Iy in terms of I1, I2 and I3. So from the network, what will be Ix? Ix is going downwards. But for here it is going clockwise, so it is upwards here. So Ix equal to minus 1. First equation. Similarly, what is Iy here? So it is interfering with I2 and I3. So the same direction is I2. So Iy equal to I2 minus I3. Second equation. Then apply KVL to mesh 1. So what is it? This thing. But it is a super mesh. So what will write? Mesh 1 and 2 form a super mesh. Then what will do? Directly you can write in terms of current. So same direction is I2. So I2 minus I1 equal to 0.5 Ix, and Ix is minus I1. So therefore I2 minus I1 equal to minus 0.5 I1. So therefore I1 will go here. So 0.5 minus 1 is minus 0.5. So minus 0.5 I1 plus I2 equal to 0. Equation number 3. Then apply KVL to super mesh. What will be the super mesh? I'll use a brown sketch pen. This is the super mesh. So let's go in this direction. Let's start from here. So you are going from positive to negative. So plus 50. Apply KVL to mesh 2. So plus 50 minus 10 times what will this be? I1 minus I3. I1 minus I3 minus 6 times I2 minus I3 minus 8 I2 minus 52 equal to 0. So there is no extra unknown like Ix and Iy, so we can directly solve this. So I1 is only one term, minus 10 I1, I2 is minus 8 minus 6 minus 14 I2, I3 is 10 I3 plus 6 I3, so 16 I3. 50 minus 52 is minus 2, so when it goes to the right side, plus 2. So equation number 4, right? So finally we have to apply KVL here. So applying KVL to mesh 3. So what will we get? Let's start from here. So we go like this and we come here. So like this, minus 5 Iy. Minus 5 Iy. So like this we come here, plus to minus. So minus 6 times I3 minus I2. Plus minus minus 10 times I3 minus I1. Minus 10 times I3 minus I1 equal to 0. So we have extra unknown Iy. What is Iy? I2 minus I3. So substitute here. So minus 5 times I2 minus I3. What will this become? Plus 6 I2 minus 6 I3 plus 10 I1 minus 10 I3 equal to 0. So first we'll prefer I1. So 10 I1, only one term is there, minus 5 plus 6 minus 1. So minus I2 plus 5 minus 6 minus 1 minus 10 minus 11 I3. This is minus 5 plus 6. So plus I2 equal to, there is no constant term, so equal to 0. So 5. So solving 3, 4 and 5. So just substitute in calci. We get what? I1, I2, I3. So equation number 3 we have to start with. So minus 0.5 I1 plus I2, 0 I3, 0 constant. So equation number 4, minus 10, minus 14, 16, 2. And finally equation 5, 10, 1, minus 11. So I1 is minus 1.157. I am directly writing plus value. You have to start with minus and then make it plus. 9 amperes anti-clockwise. I2 is 0.5789 amperes anti-clockwise. Don't forget the units. And this is 1.1053 amperes anti-clockwise. But we have to find current through 8 ohms. So what is current through 8 ohms? It is nothing but I2 only. I2 is going like this. So it is nothing but current through 8 ohms. So equal to I2 equal to 0.5789 amperes anti-clockwise direction. Okay. So this is the way we have to solve sums on super mesh analysis using dependent sources. Okay. So make sure, again I am reiterating the fact that you have to solve it, and don't just solve orally by seeing the video. Okay, I'll do it in calci. It is not possible. Okay, practice with calci is also important. I am also using calci in front of you. So make sure you also use calci. Thank you.